Okay, today we're gonna go over exponents. Let's take a look at some rules. Cassandra, if you can hear me, please put a check mark next to your name so we can start. Okay, let's start with some basics. When you have a to the power of m times a to the power of n, Cassandra, can you tell me what this would be equal to? That would be a to the power of what? If you don't know, you can put the X mark next to your name. That's fine. If you know it, just type the answer for me. Yes, you add the exponents m plus n. So this would be an example for this would be if I have 2 to the power of 2 times 2 to the power of 3. As you see here, 2 to the power of 2 consists of 2 2's, and 2 to the power of 3 consists of 3 2's, and if you look at here, you have a total of 5 2's, and that's why we say it's 2 to the power of 2 plus 3 that confirm the result. It should be 2 to the power of 5. The next one, if I have a to the power of m times, and then we have the whole thing to the power of n. Cassandra, can you tell me what that would be equal to? Would be a to the power of what? What would be the exponents here? Okay, yeah, let's take a look at the example. Let's put the x. Here we have, looks like Barbara is back. Barbara, if you can hear me, go ahead and put a check mark next to your name. Here, if I have 2 to, thank you, if you have 2 to the power of 3, and then the whole thing is to the power of 2. That's what we're looking at, Barbara. The first one, we have, if I have a to the power of m times a to the power of n, we established that would be a to the power of m plus n. We add the exponents, and we look at the example here where we have 2 to the power of 2 times 2 to the power of 3, and then 2 to the power of 2 would be 2 2's, and 2 to the power of 3 would be 3 2's, and then we would have a total of 5 2's, and that would confirm the result of adding the exponents. Barbara, do you follow the first one that we have here? If you do, go ahead and put a check mark next to your name, please. So if you have the same base, different exponents, you add the exponents when you multiply them. Now the second one, we have 2 to the power of 3. It means we have 3 2's here for the base. And then each of these should raise to the power of 2. So each of these would be 2 to the power of 2, 2 to the power of 2, 2 to the power of 2, and see how many 2's we get out of those. Each of those would consist of 2 2's, so we have 2 2's for the first one, and then we have 2 2's for the second, and also 2 2's for the third one here. So how many of 2's we have here? We have a total of 1 2 3 4 5 6 2's. So it looks like we have 2 to the power of 6. Now, Cassandra, can you tell me what were you doing here? How do you get 6 here? If I have 2 to the power of 3, the whole thing to the power of 2, what do we do with the exponents then? We don't add them again. What do we do then? We multiply them, exactly. So that would be m times n. Exactly. So it would be 3 times 2. And that's why we would get 2 to the power of 6 here. So we're looking at 2 properties here. And if you both can follow these 2 properties, could you please put a check mark next to your name, the one I put the star next to it? Okay, Barbara, you follow that, great. Now let's move on with the next one. Let's say I have A times B to the power of m. Now, when you don't have any exponents inside the parentheses, that means the exponent originally is 1. So you can put the imaginary 1 here. So Barbara, can you tell me what this would equal to? That would be a to the power of what? That would be very, very similar to what we had earlier. If I have a to the power of n to the power of m, we said we're going to multiply the exponents. So what do we have here? Barbara, if you cannot answer the question, just put the X next to your name so I can move on. Can you tell me what would be the exponents for A? Okay, you put I, or you mean 1. Well, no. Cassandra, you want to try that? If I apply this, if I had A to the power of, instead of n, if I had 1, and then to the power of m, well, wouldn't it be obvious that that would be a to the power of, instead of n times m, I would have 1 times m. So what do we have here? That would be a to the power of 1 times m would be m. And then here would be b to the power of 1 times m. So this would be the same as a to the power of m times b to the power of m. If you follow this concept, could you please put a check mark next to your name? Barbara? Great. All right, let's see. What if I have a over b inside the parentheses to the power of m? Again, the exponents inside the parentheses must be equal to 1. All right, so Cassandra, can you tell me what do we get at the top of the fraction here? We get a to the power of what? This question would be m. Very good. 1 times m would be simply m. Barbara, can you tell me what we have at the bottom of the fraction? That would be b to the power of what? Okay, Barbara. Similarly, we have to multiply m times 1. So what do we get here, Barbara? 1 times m, exactly, which is just m. Okay, if you can follow these two properties, could you please put the check mark next to your name? Barbara? Okay, let's look at the quick review. So far we had a to the power of m times a to the power of n, and then we have a to the power of m, the whole thing to the power of n, and then we have a b to the power of m, and a over b to the power of m. Okay, so the first one would be a to the power of m plus n. We add the exponents. Second one would be a to the power of m times n. The next one would be a to the power of m, b to the power of m, and then the last one would be a to the power of m over b to the power of m. Okay, I'm going to give you a few minutes, Cassandra, to work problems 1 through 3, and when you're done, put the check mark next to your name, and we move on. Okay, this question would be for Cassandra. What would be x to the power of 1 on the first one? I see you've been having some problem logging in. You're getting disconnected, Barbara. That's okay. So the first one would be x to the power of 9 plus 4. That's correct. That would be x to the power of 13. Very good. Okay, Barbara, how about the next one? That would be m to the power of what? Question would be for Barbara. Yes, that would be 7 plus 8. So we have m to the power of 15. Okay, Cassandra, how about the next one? That would be minus 5, that's our base, to the power of what? What would be the exponents, Cassandra? That would be 2 plus 4, very good, which is equal to minus 5 to the power of 6. What is minus 5 to the power of 6 equal to? Okay, it's like you take negative 5 and multiply it by itself 6 times. 5 times 5 times 5 times 5 times 5 times 5. Okay. What would be the answer if we raise this to the power of 6? You can use your calculator. Okay, Cassandra says 15,624. Would it be positive or negative? Positive, right? Because the exponents and the exponents here is even number. When you multiply even numbers of negatives together, the result would be positive. If these exponents were odd, then you would get a negative answer. Okay, if you can follow this, please put a check mark next to your name. Okay, very good. Let's move on to the next one. All right, I'm going to give you a few minutes to finish 1 through 3 and put the check mark next to your name when you're done. Okay, Barbara, what would be the first one? That would be a to the power of what? Question would be for Barbara. And Cassandra, get ready for the second one. Okay, we keep the base and we multiply the exponents. A to the power of m to the power of n would be a to the power of m times n. Looks like Barbara has a problem with her connection today. Cassandra, what do you get for the first one? That would be a to the power of what? (10). Multiply the exponents, and very quickly, Cassandra, what do you get for the second one? That would be to the power of 24. And finally, we get 3 to the power of 2 times 2, which is equal to 4. Very good. All right, it's a very simple calculation here so far. So let's move on to the next one. Now, some examples for the power rule part B. Let me give you a few minutes again to evaluate these. And when you're done, put a check mark next to your name. Okay, Cassandra, you said you're done. I think we're having a problem with Barbara's connection today. All right, Cassandra, can you tell me what would be the first one? This would be a to the power of m, b to the power of m. So the first one would be a to the power of 4, very good, b to the power of 4. How about the next one? That would be x to the power of 10, y to the power of 10, z to the power of 10, very good. And the last one, you have 7 to the power of 2, n to the power of 2, and we can write this as 49 n to the power of 2. All right, very good. Let's take a look at the next one. All right, Cassandra, go ahead and follow the power rule part 3 to do problems 1 through 3 and put a check mark next to your name when you're done with those 3. Again, these are very simple calculations. Okay, great. So the first one, this would be a to the power of m over b to the power of m then. So first one would be a to the power of 7 over b to the power of 7. Very good. How about the second one? Second one would be 4 to the power of 3 over h to the power of 3. We can expand that like we did with the other ones. And finally, the last one would be 2 to the power of 2 over 5 to the power of 2, which is equal to 4 over 25. Okay, very good. Let's move on. Combining rules. Cassandra, I'm going to give you a minute to go over these three and put a check mark next to your name when you're done. Okay, these three are very similar to the one we did earlier. Let's go back, review the rules that we had here. First of all, can you tell me which properties, if I number these, rule number 1, 2, 3, and 4. Okay, Cassandra, to answer your question, can you tell me which one of these properties are you using for these last problems? Okay, remember we are looking at these. Which of those three properties are we using for these three? Rule number 1, rule number 2, or rule number 3 or 4. Let's go back to the rules again. Now, which one of these properties are you going to use? Number 1, 2, 3, or 4? Let's start with that one. You said 4. Well, with the 4, we have to have a fraction here and only one term. So that's not the case here. If you look at this example here, first of all, we have 2. We have 2 terms multiplying each other, right? So let's go back to the rules again. Cannot be number 4 then. Which one of these rules you have 2 terms multiplying each other? No, number 2 also is not it, because number 2 you only have one base and then you have the exponents. It just happened to be your base be exponents also. So it is not number 2 either. Number 3 also is not it. So number 3 also you have one base here. Look back your questions again. Now we have 2 numbers with the same base multiplying each other. So going back to the rules again, can you tell me which one matches that? Which one of these rules contains 2 numbers with the same base multiplies each other and different exponents? Right, exactly. It's number 1. The only difference is your a is a fraction itself. So let's go back to the one we were doing. Here we have to apply still a to the power of m times a to the power of n, and we keep the base a and we add the exponents. The only difference here is your a is a fraction. A could be any number. So if I have a to the power of m times a to the power of n, in this case we have 1/2 to the power of 3 times 1/2 to the power of 2. So your a in this case, like we said, is 1/2. So that would be 1/2, we keep the base, to the power of what? What would be the power, Cassandra? 5, exactly. 3 plus 2. Then we have 1/2 to the power of 5. Very good. That would be 1 to the power of 5 over 2 to the power of 5, of course, right? Okay, how about the second one? We would get the base is 4v. So we have 4v to the power of what? Again, your a is 4v. And then you simply add the exponents. Exactly, it would be 3 plus 5. So it would be 4v to the power of 8. Again, this would be the same as 4 to the power of 8, v to the power of 8. And finally, last one, we have minus 2t, that's our base, to the power of what? Sandra, what do we have here? Your m is 2, and your n must be 1 here. I mean, there's no exponents. So what do we have here? That would be minus 2 to the power of 2 plus 1, exactly, which is equal to 3. Minus 2t to the power of 3. Can you go one step further and tell me what is this would be equal to? Cassandra? Minus 2t to the power of 3. What is that equal to? This would be like minus 2 to the power of 3 and t to the power of 3. Very good. That would be minus 8 t to the power of 3, as you see, because the exponent is odd and the base is negative, and the whole thing stays negative. If you can follow all these, can you put a check mark next to your name, please, Cassandra? Excellent. All right, let's move on. Okay, again, combining rules. I'm going to give you a minute to go over these, and you have to tell me which of those properties you're going to use. And when you're done with them, just put a check mark next to your name. Okay, your question now, you say you're okay with number 4, and then you have no problem with number 5 and 6. So let's go ahead and tell me, what do you have for number 4? First of all, let's go back to those property again and tell me which of these properties are you going to use now. Property number 1, 2, 3, or 4. Which of these rules are you using? Okay, you said number 2. That is correct. So let's go back to our question. So we are going to use a to the power of n to the power of m would be a to the power of n times m. Also, if we have more than one term inside the parentheses as a base, we follow the same thing. So if I have a to the power of n, b to the power of m to the power of w, for instance, that would be a to the power of n times w, b to the power of m times w. Just multiply. Okay, so for the first one, we would have d to the power of something, e to the power of something. So let's start with d first. What would be the exponents for d, Cassandra? Remember, when there's nothing there, it's 1. So that would be d to the power of what? 8. Very good. 1 times 8 is 8. And that would be e to the power of, what would be the exponents for e then? 16. All right, so that's done. That's easy. Now, the second one would be very similar to this. Now we have 3 terms. So we have 2 to the power of something, r to the power of something, s to the power of something. So let's start with 2. Remember, the exponents for 2 inside the parentheses is 1 then. So can you tell me, Cassandra, what would be the first one? 2 to the power of what? What do we get here? 3. 1 times 3. 3. Very good. The second one would be r to the power of, what do we have here? 15. You simply multiply them. Very good. And s to the power of what? 12. As simple as that. Do you follow that now? Okay, very good. So let's do the last one then. Last one, we have w to the power, what would be the first part? W to the power of what? You multiply the exponent would be 12. Right? 3 times 4 would be 12. And the second one would be times w to the power of 2 times 8, which is 16. Now we are back to another rule here now, right? Now we have same base, different exponents, you multiply them. Exactly, rule number 1. So we're back to rule number 1 here. So it would be w to the power of 12 plus 16. So it would be w to the power of 28. Very good. All right, you got it. Let's take a look at the next one. Let me give you a minute to go over the next set, and when you're done, go ahead and put a check mark next to your name. All right, so here we have 3f to the power of 2, and then we have fh to the power of 4. Now, which rule are we going to use here, Cassandra? Rule number 1. Well, first start with rule. Are we using rule number 1, yes or no? Okay, remember the rule number 1. Go back to the rules again. The question is, are we using rule number 1? If your answer is yes, put the check mark next to your name. If not, put X or put yes or no. Okay, Barbara says no. Cassandra, what do you think? Okay, we cannot use, when you use rule number 1, you have to have the same base. You notice that here? You have to have the same exact base. A must be the same. And we keep the base, we add the exponents. Right? So in this case, we don't have that. The base for the first one is 3f. Base for the second one is fh. So we cannot use rule number 1. Individually, we can use different rule though. Okay? Which rule are we going to use for? Okay, so we are using rule number 2 then for each of those. Okay, you said rule number 3. Well, yeah, or rule number 3 if you have more than one number inside the parentheses for your base. So let's take a look at that. So the first one would be 3 to the power of 2 f to the power of 2, and then the next one we have f to the power of 4, h to the power of 4. If you can follow up to this point, can you put a check mark next to your name? You're using the fact that if I have a b to the power of n, that would be the same as a to the power of n, b to the power of n, basically. Okay, good. Now I can combine some of these because I have the same base, different exponents. These two can be combined into f to the power of something. Cassandra, can you tell me? 2 plus 4, exactly. And the first one, you have 3 to the power of 2, which is simply 9. And h to the power of 4, I cannot do much with this because I don't have the same base. So it would be 9 f to the power of 6, h to the power of 4. Okay, can I see a check mark if we can follow that one? Barbara? Okay, number 8. For number 8, again, we don't have the same base here, so each of those should be raised to the power of 6. So the first one we have 7 to the power of 6, a to the power of 4 times 6, 24, and c to the power of 2 times 6, 12, over b to the power of 5 times 6. Okay, can I see a check mark next to your name if you can follow up till this point? Okay. The question is, can I combine these? Barbara, are you okay with this so far? We're just raising each of these to the power of 6, and the exponents for 7 is 1. Very good. Now, can you, yes or no, can I combine these? Right, I can write 7 to the power of 6 as what the number is. But as you see, the base for all of these are not the same, so I cannot use any of those rules to go any step further. Okay, we got disconnected momentarily again. I'm not sure what's wrong with this program today. If you can still hear me, put the check mark next to your name so we can move on. Okay, thank you. All right, let's continue again. First one would be 5 to the power of 2, j to the power of 10, we have k to the power of 6, m to the power of 2. And then for the second one, we have k to the power of 3, m to the power of 3 times 5, which is 15. If you can follow up to this point, can you put a check mark next to your name, please? Okay, good. Okay, Barbara, you have a problem here. What's the question? Because all we're doing here is to raise this, since exponents is 1, raising this to the power of uh, 2 and 3. Now your question is, why not k to the power of 5 is equal to 2 plus 2? Okay, you're talking about the k here. Are you referring to this k right here? Okay, here let's go back to the rule again. We have okay, we keep getting disconnected today. I'm not sure why. Again, if you can hear me, please put a check mark next to your name. Barbara, can you hear me? Okay. Now your question was on k. Now when we have k to the power of n to the power of m, this would be k to the power of n times n, and that's what we're doing here. If you had k to the power of n times k to the power of m, this is the time when you add them. It looks like you got it. All right, great. So let's move on. And now we can go ahead and combine the one with the same base. We have k here. So we have k to the power of, now we can add these two. That would be 6 plus 3. And the next one, we have m to the power of 2 plus 15. And then we have j all by itself, and then 5 to the power of 2 we can write as 25. So we have 25 j to the power of 10, k to the power of 9, and m to the power of 17. If you can follow this, could you please put a check mark next to your name? Barbara, do you follow that now? Okay, you have to know the difference between these two. So let's go ahead and ask you, do you follow up till this point where I put the star? Do you get it up till this point? Put a check mark next to your name if you can follow up to that point. Okay, so my question to you, Barbara, is do you follow up till this point here where I put the star? If not, I have to go back and explain that. If you follow up to this point, put yes or no so I can move on. And okay, so that's the problem that you have there. Okay, so let's take a look at this very quickly. We have 5j to the power of 5, k to the power of 3, m, the whole thing to the power of 2, and then you have k, m to the power of 5, the whole thing to the power of 3. So let's take a look at this in a little bit more detail. Okay, so what we have here is 5 okay, j to the power of 5, k to the power of 3, and then we have m to the power of 2, then we have k to the power of 1, it's m to the power of 5, the whole thing to the power of 3. That's what we're doing. Now look at the properties that we have here. A to the power of n to the power of m would be the same as a to the power of n times m. A to the power of n times a to the power of m is the same as a to the power of n plus m. So if you have the same base, different exponents, you add the exponents. Otherwise, you would multiply the exponents if you have one base and multiple exponents. Do you follow these two rules, first of all, Barbara? Just put yes or no so far. Okay. Now, the first one, obviously we don't have the same base here. So what we need to do is to use property number 1. Also, another property we had was if I have a b to the power of n, each of these would get to the power of n also. This would be where the exponents here would be like simply 1. Or if instead of 1 you had any other exponents, you just simply multiply them together like n times m. So the first one would be 5 to the power of 1 times 2. Next one would be j to the power of 5 times 2. Then we have k to the power of 3 times 2. We have m to the power of 1 times 2. And we move on, k to the power of 1 times 3. M to the power of 5 times 3. Barbara, do you follow up to this point? Again, the exponents for k is 1. If you can follow up to this point, put a check mark next to your name, please. Good. All right, so that's all we're doing here. We have 5 to the power of 2, j to the power of 10, k to the power of 6, m to the power of 2, k to the power of 3, m to the power of 15. Okay, do you also follow up to this point then, Barbara? Good. All right, now we're going to look and see if we can combine any of these if we have the same base. Remember this rule here. I have 2 terms here that have the same base in this k. That would be k to the power of, Barbara, can you tell me what this would be equal to? K to the power of what? The exponent here is 6. The exponent here is 3. So according to this, I have to add them, right? Yeah, right. It would be 6 plus 3. And for the m, you write m to the power of 2 plus 15 the same way. Now j is all by itself, so I write j to the power of 10, and 5 to the power of 2 is equal to 25. Do you follow up to this point, Barbara? Okay, good. So that would be k to the power of 9, m to the power of 17. Okay? All right. Okay. Well, this is it for today. We went through some rules for exponents. We practiced them. You need to complete all these handouts with your full name and your instructor name and today's date, and turn it in my office. Read the email I sent you for more information about that. D107 inside the math lab. You turn in the handout. You can slide it under my door if I'm not there. Okay, and regarding the handout, rule 4, I can go back, Barbara, to you can copy the rules now. Like I said, you have to go over entire session again because you missed some parts as you were getting disconnected today, and make sure you take care of that. All right, if you don't have any more questions, you can go ahead and click on the door out, and I'll see you next time. Please log in and request for next workshops, and we'll see you next Friday. Thank you.